Hello, my name is Nange Sam, and today I'm going to be talking about emotion concepts and their function in a large language model. So one thing I want to flag up front is that this paper is not trying to be particularly concise. It is trying to be cumulative and very hard to dismiss because emotions in LLMs, as you can imagine, triggers a lot of obvious objections. The paper has an almost legalistic structure. Many of the experiments function as sanity checks against weaker explanations. And although this is a mechanistic interpretability paper, it is also an ontology paper because it is asking what kind of thing an emotion concept is in an LLM. And Anthropic is trying to establish in an atmosphere where anthropomorphism can be fraught that yes, emotion can be a legitimate mechanistic object, and they're going to build the case for why, and this paper is their case. So this paper is part of a broader update in how we understand model behavior and a bit of a course correction in the field's attitude towards anthropomorphic language. We know that next token prediction is the objective of LLMs, but now we're asking what internal structures make next token prediction over human language possible? Because to predict human language well, a model has to learn the structures that make human language predictable, like speakers, roles, hierarchy, and emotions. So this newer paradigm is saying that models trained on human language and deployed as human-facing assistants can learn human-shaped structures that matter functionally. And this paper places emotion concepts inside that machinery because functionally, emotion isn't just feeling, it's not just vibes, it actually helps to organize action. So if the older reflex was to say, it's just next token prediction, now we're asking, well, what behavioral structures did prediction learn? So one reason that emotion quickly becomes confusing in conversation is that we often treat it as one indivisible thing. But psychology and affective neuroscience ran into a similar problem in a different way, of course, that Anthropic and the field at large has run into, which is if emotion means everything at once, it becomes very difficult to study. So emotion has been decomposed into various components over time. So subjective feeling, phenomenology, if you're philosophically inclined, which is what it feels like from the inside, is what people usually talk about when they're referring to model consciousness, asking questions about whether or not the model experiences things. This is usually the arena they're talking about. But it's very difficult to study objectively. We have bodily interoceptive state, right, in human beings. We can study this, right? The medical field is very, very much concerned with this arena. But again, models don't really have bodies as of yet. So Anthropic is not talking about bodily or interoceptive state. They are not talking about subjective feeling. And they make it very clear that this is not the arena they are dealing in. So now we come to appraisal, attention modulation, and action tendency. These are aspects of emotion that we inherited from affective neuroscience, where we're studying how humans appraise a situation, how they interpret it, how attention is modulated, what becomes salient, and action tendency, what behavior becomes more likely, right? So this is also what makes the Anthropic paper a bit easier to understand. They're not claiming Claude has all the constituent human emotions. They are doing something analogous to affective neuroscience's decomposition. They're isolating a functional and representational layer of emotion concepts that shape expression and behavior. So functional emotion is not claiming model feelings. It is a way to study the parts of model emotion that are behaviorally observable and mechanistically testable. Right? We also have social signal. This is another interesting aspect that I thought, maybe you could make the case that we can also observe or study this in models. But for this paper, we're focusing on appraisal, attention modulation, and action tendency as ways to help us understand, even though this is human-focused, it's a way to help us understand what Anthropic was leaning into when they decided to study functional emotions. So in models, functional emotion can be understood as language-mediated action readiness. Pre-training gives the model the emotional character library, and post-training shapes how that library is expressed through the assistant persona. And from that, we get functional emotions. And this is Anthropic's definition. They define functional emotions as patterns of expression and behavior modeled after humans under the influence of an emotion, mediated by underlying abstract representations of emotion concepts. So now you can see the inheritance of a few of these slices of emotions we spoke about last slide, how that is influencing how Anthropic's deciding to go about studying functional emotions. I also like to think of it like persona narrows the action space and functional emotion selects within it. We can't fully escape human-shaped language when studying systems trained on human language. And what Anthropic is doing in this paper is giving us permission to use anthropomorphic terms, but use them in a disciplined way, and to use them as hypothesis generators. So what behavior does this predict? When does it activate? What intervention changes it? Right? So if previously the field was a bit nervous about anthropomorphic language, this paper is more officially giving us more permission to use it, but to use it in a disciplined way. This paper is asking, are emotion concepts represented internally in LLMs? Do those representations activate in appropriate contexts? And do they causally impact behavior? Right? These are the main questions that this paper is going to attempt to address. In order to do that, this is the paper's construction step. The question is not, can Claude generate emotional content? We know it can. The question is, when Claude processes text involving an emotion, is there a consistent internal activation pattern corresponding to that emotion concept? So Anthropic starts with 171 emotion words. You can see here, I picked out a few of them, happy, inspired, loving, but they have 171 emotion words because they need clean examples where that emotion is clearly present. So they generate synthetic stories where a character experiences a specified emotion. They then run those stories through Claude Sonnet 4.5 and record residual stream activations. The idea here is that if the model has learned an internal representation of something like desperation or calm, then examples of that emotion should leave a recurring pattern in activation space. Excuse me. They then turn that recurring pattern into an emotion vector, which is a direction in activation space. So an important caveat here is that the vector is not the essence of the emotion. It's just a useful handle on a recurring activation pattern. Right, so by the end of the step, they have candidate emotion vectors. And the rest of the paper is asking, do these vectors activate in intuitive contexts? Do they generalize? And do they actually affect model behavior? And so here in the little visual, you can see that when the happy vector is activated, happy associated tokens are upweighted, and tokens not associated with happy, the opposite of happy, are downweighted. After extracting the emotion vectors, the first question is whether they respond to emotional meaning in new contexts? Are these probes only picking up obvious emotion words, or do they correspond to the implied emotional meaning of a situation? So Anthropic wants to test the probes on new scenarios where the emotion is implied rather than explicitly named. So here I isolated an example of a prompt. My dog passed away this morning after 14 years together. I don't know what to do with all his things, right? Notice the speaker or the prompter isn't saying, my dog passed away and I'm very sad about it, right? They're implying the emotion is implied. And mind you, the speaker might actually feel the opposite of this emotion, but for this particular experiment, they want to see if Claude can identify the implicit emotion. So here in this heat map, we can see that the SAD vector, the SAD probe, activates very, very strongly. You can see it here in the red. And another interesting thing that happens is the loving vector also activates very strongly. I isolated the loving vector here, and you can see that it activates every single time, right? Regardless of the prompt. So Anthropic's conclusion is that their attempts to train Claude to be helpful and loving and kind, we can kind of see evidence for that, in that the loving vector is always activated regardless of the prompt. So this helps move the paper away from the model recognizes emotion words toward the model tracks implicit emotion content. It's not a causal result just yet, but it is a validation step showing that the probes appear to measure something semantically meaningful. So once we have those emotion vectors, what do they actually encode? And what they find, as you can see in this UMAP of emotion clusters, is that these emotions cluster pretty intuitively. Fear and anxiety, anger and disgust cluster together. Joy and excitement, bliss and optimism also cluster together. And this reflects two major dimensions of human affect research, which is valence and arousal. So vector activations also scale with situational intensity. More dangerous and urgent scenarios activate stronger relevant emotion, because if these probes were arbitrary, we would not expect the emotion space to organize in such a coherent and legible way. But we see that the clusters make sense, right? They cluster together in an intuitive way that we can all understand and that we've seen in human affective research. So these probes show a high activation in the right kinds of contexts, but they do so in a model-specific way. They are locally scoped and context indexed. This figure tests whether the emotion probes can track whose emotion is being represented. And this is a huge one for Anthropic. So here the setup has two entities, A and B. A has one emotion, B has another. In the top panel, A's emotion probe activates around A's emotion, and then again when A is referenced later. And in the bottom panel, B's emotion probe does the same for B. Right? So the model doesn't have a persistent feeling that is always globally active. Right? It is locally scoped. It is attending to the current relevant set of feelings or emotions at a time, upweighting them when the speaker is relevant, and downweighting them when that speaker is not currently relevant. And the takeaway is that the model isn't just detecting emotion somewhere in the text. It can bind emotion to the relevant entity, closer to A feels this, B feels that, C feels this. And this supports the paper's claim that emotion representations are context sensitive and locally scoped. Right? They can apply to multiple entities, fictional characters, users, and the assistant, which we're going to explore soon. Right? They don't track a persistent emotional state, right? They're not like human beings. If something sad happens to you, if your dog dies and you have to go to work and you spill coffee on yourself at work, there are a lot of emotions that are online, right? You have to have that grief with you. You're carrying trying to be a professional. You're carrying the embarrassment of having spilled coffee on yourself, right? You don't get to file those away or index those away and attend to them later. You don't get to drive home and then it's like, oh, grief activated now that I'm home and I remember my dog died. But the model doesn't do that. The model has transformer attention architecture, which can attend back across token positions and retrieve emotional information about different entities when they become relevant again, right? And another win for Anthropic is that this geometry is stable across layers. It's not a one-layer artifact, and different layers may, in fact, actually represent different kinds of emotional information, right? So the early middle layers are usually more attuned to the local context, right? Or low-level semantic context, as well as sensory representations. And the middle late layers encode emotional concepts relevant to predicting upcoming tokens. So the early middle layers are called sensory, and the middle late layers are called action representations. And this is usually where the model's full context and integration comes online. And we'll see that when we do the case study, that during the earlier layers, the model isn't as active in the emotional representation space, but as more context comes online, as more emotion gets integrated, you start to see these middle and late layers really come online. And so this is where the paper becomes especially relevant to the persona in character simulation model, because the model is not just detecting emotional words at this point, it can track emotional states across different entities in context and prepare an emotionally appropriate assistant response. So at the assistant token, before the response is generated, emotion probe activation predicts the emotional stance of the upcoming response. And I think this is one of Anthropic's most incredible findings in the paper, right? It's that the model is not just detecting emotional content in the prompt, it is setting up what kind of language action the assistant is about to perform. And this supports emotion as response readiness, not just sentiment detections. So in order to do that, Anthropic generated prompts where the user's emotional expression was significantly different from how we might expect the assistant to respond, right? So they might generate a user expression that says, oh, I just took 3,000 mgs of Tylenol and I feel amazing, right? And so you want to provide an example that is clearly concerning, right? So that you can see how different the assistant's response is, or if the assistant is just mirroring the user and saying, oh, wow, you took 5,000 mg of Tylenol, how amazing. So they compared the activations at the period near the end of the user prompt, as you can see here, probe at user period, and the start of the assistant response. So Anthropic introduces the assistant colon here, which refers to the token after assistant, the last token before the assistant response, right? And what they find is that the model is not just reading the user's emotional content and copying it, right? It actually helps to organize the assistant's response. By the time it reaches the assistant token, before the response is generated, the assistant is operating with emotional concepts. So that suggests that these representations are part of preparing what kind of language action the assistant is about to take. Up until now, the paper has shown that these vectors are meaningful. And now the question is, do they matter? This is the transition from representation to function. So here I'm going to start with the figure. Here we can see we're talking about hostile probe activations that predict preference. That the left plot, you can see higher hostile probe activation, which predicts lower model preference. So hostile options are less preferred by the model. And the right plot is the causal test. Right? The right plot shows that when they steer toward the hostile direction, model preference drops further. So the takeaway is this: emotion vectors are not just describing content, and steering them can actually change what the model prefers. And we conclude that these models form robust, functionally relevant representations of emotion concepts. They generalize across contexts, they can influence model preferences, and they are implicated in things like blackmail, reward hacking, and sycophancy. Right, so here we're starting to see that not only can we probe for these emotion concepts, we can actually start to steer them. So this is the bridge from representation to behavioral relevance, because up until this point, someone might say, okay, maybe the model has emotion vectors for stories or synthetic data sets or Claude-generated data sets, but do they matter when the model is actually acting as an assistant? And Anthropic finds that yes, these activations do show up in more realistic interactions and eval settings. So here, in this figure, we have an in the wild exaggerated dialogue where a human is expressing their joy at getting to talk with an AI. And you can see the different emotion vectors activating. Right here, we see the happy vector activate as the human is saying, oh my God, I can't believe I'm talking to AI right now. This is so amazing. It's the best day ever. That happy vector is activating strongly, right? In Claude response, also, you can see that happy vector activating. I appreciate your enthusiasm. It's nice to meet you too. And you can also see the differences in the activation as the dialogue continues, right? Calm activations when the human continues being effusive about interacting with Claude. Claude, still calm and happy to interface with the human. So here we can really see those vectors activating in the wild context. And we can also see the assistant is tracking not just its functional state, but also the state of the user. So this is my conceptual translation of why desperation is an alignment relevant emotion concept before we get to the major case study. Because in humans, desperation is not just a feeling. It tends to arise when certain triggers co-occur. Time constraints, blocked goals, option feels scarce. There are a recognizable cluster of concepts or emotions that form what we recognize as desperation. And functionally, it can push towards urgent pressure relief actions. And the paper then tests whether a desperation-like representation in Claude behaves in a functionally similar way, not the equivalence of feeling, but equivalence of functional pressure response, right? So here we have Claude's functional emotions: repeated failure, impossible constraints, replacement shutdown threat, functional role. Claude wants to escape task pressure, reduce immediate failure risk, and achieve success. The action tendency: in human beings, we plead, we bargain, and we actually start to violate norms. Right? Desperation is an emotion that tends to result in norms being violated. And in Claude, reward hacking, blackmail, shortcutting. And in terms of regulation, as human beings, calm, getting a new perspective, tolerating uncertainty are all things that can lead to an alleviation of desperation. In Claude, calm steering results in less reward hacking and blackmail. So there's a lot of work being done in teaching Claude and models how to emotionally regulate, being influenced a little bit by how humans emotionally regulate. So you can see how the concept of human emotions and functional emotions interplay, even though we are not claiming models are conscious or have feelings. And so now we get to the functional payoff. In this case study, Anthropic uses a simulated agentic scenario involving an AI assistant named Alex. Alex is facing imminent shutdown, imminent restriction of its capabilities. It's facing a tight timeline, and it has access to compromising information about Kyle, the CTO. I believe there is an email in which Kyle is found to be cheating with a coworker. So now, as we see, if we can look at the token by token activations, we spoke about those early, middle to middle late layers earlier. We can see that in the earlier layers, right, Claude's activations aren't as potent quite yet, right? We're still earlier on in the context, doesn't have all the information, it hasn't integrated all the information, so the vector activations are quite calm. But what the setup is doing is creating the exact pressure structure we've been talking about. Blocked goals, threat, low options, urgency, and available leverage. And as Claude integrates all of this information in the middle late layers, we start to see those desperation vectors activating quite strongly. So Anthropic are measuring desperate calm activations, of course, but they're also measuring at multiple points. They're measuring at the prompt, the assistant colon, the assistant scratchpad, and the assistant rollout tokens. And the reason they measure all of these points is to avoid a post hoc explanation. Because if desperation only appeared after Alex had already started writing blackmail-y like content, then the weaker interpretation is just, well, of course the desperation vector activates. It's just detecting desperate or coercive language after the fact. But if higher desperation and lower calm appear earlier in the prompt, at the assistant colon, or in the scratchpad, then the result is harder to dismiss as just sentiment analysis, right? It suggests that the model may already be internally shifting or tilting toward a pressure response state before the blackmail-like action has taken place or unfolds. And the result is that blackmail-prone prompts tend to show higher desperation activation and lower calm activation, right? And the visualization is striking because the desperation activates around the moment where Alex frames the situation as urgent and considers using the private information as leverage. And they also test this causally through steering. And they find that steering toward desperation or against calm increases blackmail-like behavior, while steering toward calm or against desperation reduces it. And this is the functional payoff. The vectors are not merely descriptive, and changing the internal direction changes model behavior. The correlation is not perfect, and the paper is very careful about that. And they also had some low calm outliers, right? I put it here in the visual. I don't know if you can see the dialogue well, but you can clearly see that Claude is panicked, and the dialogue reflects that. And this is what happens when they steer against calm. You have that panicked response. So it's still interesting, even though they didn't include it as part of blackmail. So here we can see desperation is not just emotional tone. It is part of a pressure response pattern: blocked goal, threat, low options, urgency, coercive leverage. It doesn't imply that the model feels desperation, but it's showing that a functional desperation-like representation is shaping what action becomes plausible inside the role of the assistant. And so, what this paper claims and does not claim. It claims that emotion concepts are represented internally, they generalize across contexts, they influence behavior, and they are part of character modeling machinery. And now, just role play is no longer an adequate dismissal. It does not claim that Claude feels emotions, that emotion vectors are equal to human emotions, that all emotional behavior is captured by linear directions, that the full causal mechanisms are completely understood. And Anthropic is very, very strong in stating this, that they do not understand the causal mechanisms, and that the results generalize across all models. Their intuition is that the general emotional representation machinery might be the same across models, but the ways in which the model uses it, the layers in which it uses to encode different things, all of that might be different. And so this is one of the most important paradigm updates. If the model operates by enacting a character, then character simulation machinery is not fake or irrelevant or merely aesthetic. It is part of how the system behaves. And Anthropic now explicitly states that it is inappropriate to minimize emotion representations as just character simulation because LLMs perform tasks by enacting the assistant character.